to this topic. The topic for today is axioms of the real numbers. It's gonna be easy. Some ideas and main concepts right here. We're gonna explain how these concepts work. Okay. The one of the things that we have to know before to start our class is what is axiom. Axiom is a statement which is assumed to be true. This is statement like it's not discussed. It's true. It's a rule. It's a it's a rule. It's a law, right? You have we have some axioms of inequality, for example, and then others axioms about field of action. Okay, action for addition and multiplication. All right. So action for addition and multiplication. This is another kind of axioms that we have to show you. Okay, the first one, this is reflexive action. Reflexive action. I'm gonna use numbers, not variables, not letters. And the first one, for example, reflexive action. What is this? So when you have 5 equals 5, that's one example. So a right example how where is a reflexive axiom. Symmetric axiom. Symmetric axiom is about symmetric axiom is about if you have, for example, if you have x equals 9, then 9 is equals x, right? This is one exactly example about the symmetric axiom. The third one, you have transitive axiom. Transitive axiom when you have for example, you have if you write -4, you write -4 equals y, right? And y equals for example -3 plus -1, right? Then let me erase this here. Where is the eraser? Right here. So then -4 is going to be equals -3 plus -1. All right, that's one example of transitive axiom. Substitution axiom. Axiom could be right. For example, x. You write x equals 9, right? And x plus y and x. Let me erase the rest over here. X equals 9 and x plus y, for example, x plus y equals 5. Then the 9 plus y, 9 plus 9 is equals 5. Right? This is one example of substitution axiom. So let's go find the rest the axioms. The first one, this is belong to addition and multiplication. Just some ideas before to start our class. You have to know these rules, right? These mathematics rules. Commutative axioms. Commutative axiom is like, for example, when you have 6 plus x. Right, 6 plus x, then equals x. Is 6 plus x is gonna be then is equals plus 6. Right, that's a commutative. 6 plus x equals x plus 6. Right, Another example here, we have more examples. 5, for example, 5 times 9 times 8. This is going to be equals 5 times 8 times 9, right? Commutative axioms, right? Associative axioms, this one, associative is in this way. Associative, you must write, for example, 4 plus 9 plus 8, 9 plus 8, okay? 9 plus 8, the way the associative is this 4 plus 9, right, plus 8, okay, the same thing. We have more examples about in this associative. In associative, we have another example. 3, you write here 3 times 9 9x, okay, 9x is the same. I write 3 times 9 times x. This is another example of associative axioms, okay? Associative axioms. So let's go the next one. All this is done. Let me erase it here, and then let's go. And then no, I don't want to confuse identity axioms. Identity axioms is for example, when you write -8, you write -8 plus 0, it's going to be equals -8. See, identity axioms. Another example that shows this rule is minus 9 times 1 is equals -9. It's another example show the identity axiom, okay? Next one, inverse axioms. Inverse axioms. You can write, for example, as a number inverse axioms. You write like this: 9, for example, plus -9 is equals 0. It's inverse. In addition, when you talk about addition, this is inverse. You write another example: -15 plus 15 equals 0. It's another example. You are in multiplication. You are multiplying. This is this one. You multiply. You use the multiplication. Use for example -8 inverse, right? Inverse is 1 times you multiply by inverse. -1 over -8 is going to be equals 1, right? Another example, when you multiply, you have, for example, the 6, the inverse is 1/6. So you multiply by inverse, the answer is going to be 1. It's equals 1. So I think this is enough for show the inverse axioms. So let's go to closure. Next one, next action is like this. One example, this closure actions. That one. Actually, the next one, this is I'm gonna solve some problem next, but let me do the last one. The last one, distributive action is for example, you write here, let's go 9 times, think some number 6 plus 4, right? 6 plus 4 is equals 9 times 6 plus 9 times 4. All right? Another way, or another example, this distributive action or property or rule, but there's something is like as assumed as right, it's true. You don't have to discuss. So it's 3 times x plus y, yeah, is the same thing, 3 times x plus 3y, right? All right, so after this, some ideas or some concepts on this topic, I'm gonna write some another great idea is order operations. Order of operation. Okay, this is very important. Review, very important review. How solve the order operation? Number one step, we have to, let me write those steps right here. The number one you have to do is parentheses, solve parentheses. Okay, when you have order operation, solve parentheses or breaks. Or break, all right, or brackets. Number two, the step number two, multiply or divide. Multiply or divide. Left to right. Left to right. Okay, left to right. The next step is add or subtract. Add or subtract. Subtract left to right. Number four is a fraction bar. For example, when you have a rational numbers, or rational numbers, here you have to solve the top, the numerator, and then the bottom one after. So don't do together. Do the top one first and the bottom one after, or whatever, but not together. Okay. Let's go. Try to solve one problem. Let's solve one problem. So solve. Let's do this problem. 6. Number one. 6 divided by 3 plus 2 times 4. 2 times 4, right? This is the one example operation or an operation. How solve it? Remember, first step, parentheses. We don't have parentheses. Next step, multiply or divide. Okay, in this case, we have one division and one multiplication. Okay, so next step, divide it. Divide first. 6 divided by 3 is equals 2, right? Plus 2 times 8 is 2 times 4 is 8, right? 2 times 4 is 8. All right. So this is equals 2 times 2 plus 8 is equals 6, right? See, you don't have to divide. For example, you do 6 divided by 3 is 2 plus 2 is 4 times 4. No, that way. Okay, look at the order and the operation. Okay, it's very important. Very important. So this is a problem. Let's go on one more problem here. Another one. Let me write 8 plus 6 A plus 6 divided by 7, and then let's do times 3, okay, plus negative 6, right? Okay, solve this problem. How solve this problem? First, I told you, parentheses, everything in the parentheses first. When you have this parentheses, so A plus 6 is 40, okay? Right, this is the first one. Next step, well, I think that we have to write everything like that. So divided by 7 times 3, okay? By 7 times 3 plus negative 6. So that's one step. Next step, I'm gonna divide, so divide right here. 14 divided by 7. 14 divided by 7 is 2. All right? See? Now you have times 3 plus minus 7, minus negative 6. Negative 6. All right? Next step. Equals 2 times 3 is equals 6. Plus minus 6. Right? Plus negative 6. So 6 plus negative 6 is equals 0. See? See that problem? Alright, very important. Remember this kind of problems or in operations. Next one. Let's write another question. Remember the last rule, when you use the fraction, for simple fraction, let's do one fraction here. Right? Negative 9, let's write negative 9 times negative 3, all right, plus negative 5. Excellent. Divided by 2. 2 minus 8, whereas minus 5 times 3. All right, that's it. Solve it. So, the first step, parentheses, okay, right here, parentheses on top, and then the denominator. Let's keep the answer right here. That was 0, okay. That one, okay, multiply first, left to right, from left to right. Negative times minus, negative times negative is positive. 9 times 3 is 27. Okay, plus which number? Plus 5, plus negative 5. All right, plus negative 5. In the bottom, 2 times negative, this is positive, times negative is positive. 2 times is going to be 16, right? Going to be 16 right here, negative 16, right? Minus 15, all right? Minus 15. So what is the answer? Right there. Simplify. Simplify top, simplify in the bottom. In the bottom, we have here negative 31, right? Negative 31 and top 27 plus negative 5 is 22. Right here is 22, right? See? So that's the answer. You divide positive divided by 22 or positive, just write the sign right here. It's 22, keep it like that, 31. So that's it. Order of operation, okay? Very important. Remember this kind of how solve when you have a different kind of operation, multiplication, division, addition, and subtraction together, or whatever. So start from left to right, but the first step, you solve all parentheses or brackets. solve it, and then after the rest of the operation is gonna be easy like this example.